to the stage Mr. Gus Hunt.
All right, so as the only person centering you in lunch, I'm not sure if this is the right place that I actually want to be, but we'll see if we can keep this interesting for you. So I'm Gus Hunt, I'm the CTO at CAA. I'm going to talk to you a lot about stuff you've probably already heard as you've listened through the day, a lot of the same subjects, but I'm going to try and give it to you from our perspective of what's actually going on in the world, why it matters to us, and then what we think needs to change in order to actually. Real quick, in case you didn't know what we did for a living, right? The CIA has 3 business lines, all right? We collect information about the plans and intentions of our adversaries. We do this thing called all-source analysis, where we bring the information we collect together with any information we can get our hands on so that we can tell the President and the Secretary of Defense and policymakers and everybody else what it all means. And the third thing we do, and we're the only agency authorized to do this by law at the discretion of the President of the United States, is this funny thing called covert action. And so those are 3 things that we do. So about 4 years ago, when I took over as CTO of the organizations, we sat down and said, what is it that we have to be able to make sure we do well into the future? And so we set what we call our 4 big bets. All right, and big bet number 1 from 4 years ago is it's all about big data. It's about our ability to take advantage of these massive information streams that have emerged on the planet so that we can figure out what's going on in them and protect national security. That's what we do. All right, number 2, and this preceded all this talk about sequestration and things like that, but the fact is that we have a fiduciary responsibility to you, the taxpayers, to make sure that we execute every dollar we spend as well as possible. All right? But when we think about this thing, this is not a lowest cost proposition, this is the best value proposition. And for us, value is defined as outcomes divided by cost and time. More outcomes in less time is a much better value thing to get done. 3, and something that we very intently focus on, is that we have to act better together as a community. Despite what you read about the fact that there is massive dysfunction and we don't share information, all these things like that, right? It's actually not true. We actually do a really good job. It's just that every organization within anything, just like in the private sector, we come at problems from different aspects and different angles, and that creates sometimes a little discussion about what's the right way to solve some of the problems that we face. Right? And then number 4, it's all about people. Right? If you don't have the right talent, we can't execute any things that we did. Right? And then we said, all right, to accomplish these things, we're going to have an enduring framework in which we're going to invest. And so we put up these things. These are what we call our 6 key technology enablers. This is the things that we intend to invest in for the long haul in order to make sure that we are a viable, competitive organization heading into the future. And they're really simple things, and these are things that you know very well, but secure mobility for us is a huge deal. Right? Mobile is not secure. Repeat after me. Mobile is not secure. It really isn't. All right? So how are we going to make this secure in our environment so we can take advantage of it? This is a big thing. Right? The second one up there is what we call advanced analytics. This is actually analytics as a service. It's everything we want to be able to do with big data to do the jobs that we have to be able to that we have to do to support the national security of our nation. All right, the third one up there is what we call widgets and services. We got into this thing through a thing we call the Ozone Framework. The Ozone Framework is a framework that the intelligence community developed based on the Google framework. But fundamentally, it's all the same reasons you like your smartphone and your iPad and things like that, that you can personalize it and put onto it the things that you that need for your personal life or for your business life that matter to you. We need to build an environment where our analysts and our operators and other people like that can basically put on the necessary functionality that matters to them and personalize our world. And we call this a web top or a device top or any other thing you want to call it. All right. 4, which by the way is 3 on the chart, and I'm not going to explain the odd binary numbering system. It's a long story. So 4, which is number 3 on your chart, security as a service. What we want to get out of is we don't want you to have to build security from top to bottom every time you deliver or build us a system. What we want to be able to do is have a set of security services and the best practices out of what was the old services-oriented architecture world. Anybody remember that world? Okay, I'm dating myself, I'm sure. Right? But these are security services into which what happens is that the widgets and the analytics above it have to talk to the security services in the middle in order to get to data and computational infrastructure and things like that below it. And so the security services all have to be in common, and these are things that we want to make sure are very consistently enforced across anybody touching any piece of data through any analytic has to run through one of these security services. 5, it's all about data, right? And I'm going to talk more about it's the data stupid coming up here in a second. But it's all about the data. And so we have this concept of data as a service and an thing we call the data harbor. The data harbor is not a place, but it really is all about us bringing to bear these massive computational engines that so many of you out here in the exhibition hall have and are showing off. But what we have discovered, or we believe is true, is the fact that all the analytics up above often want to consume common sets of this large, high-performance computational infrastructure underneath the covers there. What we want is an environment into which all of our data and these common computational, massive computational infrastructure things are already in place so that it's very easy for us to plug in a new idea or a new capability on top because I can leverage what's already in place underneath. And then 5, in order to do all these things, it's all about massive computational capacity. Then this funny little thing called the cloud. Okay. All right. Oops, sorry, wrong button. Okay. So, did you ever ask yourself how big big was? Because we do this all the time. So I'm going to give you a quick run through on how big big actually is. All right. So how big is big, right? So you guys know Google. Google's a very big provider of things. Google stopped reporting how big it was, at least that we can find, about 4 years ago in their 2009 or 2010 SEC filing. At that time, they said that there were more than 100 petabytes in size, more than 1 trillion index URLs, right? Pretty big stuff, all right? Facebook, you know, exceeded 1 billion users, right? And I guess it was August of last year. They're way over 1 billion at this stage of the game. What's more interesting, I found, was that the latest numbers that are coming out about Facebook is that roughly 35% of all the world's digital photography gets put onto Facebook. All right? YouTube. We believe that YouTube is the only exabyte scale or bigger, repository that we've been able to come across on the planet, at least in the public sector. Across the board. And what happened was YouTube in the last filing that we saw was about 768 petabytes. If you do the math on how much data gets added to YouTube, what you find out is that from about 3 to 4 years ago, YouTube is clearly better than an exabyte. You know the world population back in about April ticked past the 7 billion mark. All right. Everybody talks about Twitter and how big Twitter is. Twitter is about 124 billion tweets a year, 4,500 a second. Twitter is a piker relative to global text messaging, right? Which is about 193,000 a second, of which 190,000 of them are generated by my daughter alone. I have the bills to prove it. Okay. And then, but even that's small relative to U.S. cell calls, right? The U.S. alone is roughly 2.2 trillion minutes a year, 19 minutes a person a day, which I find awfully small. Again, using my daughter as a measure of average, all right? That's about 2 orders of magnitude too small. Anyhow, but if you think about it, uncompressed, that's only a YouTube a year, right? So when you think about those things. All right. So what's making all this happen, right? So I think you all know this pretty well, right? There's 3 fundamental driving forces which have been around now for the past several years, and this is one little thing called social mobile cloud, right? And so it's the social mobile cloud thing which drove so much of the big data, and in fact, big data was made real because of the combination of these 3 things, right? In the social world, things go viral in a hurry. And when things go viral in a hurry, they need to have a computational space that will scale elastically with them. They brought out the cloud into existence. Everybody wants to be social, exchange information, and all this together is conspired to deliver what we just talked about, some of the big data stuff that's there. All right. This has been a dramatic increase in the velocity of innovation. Any of you who are startups today, what happens? Do you actually ever go to your investment companies, except in very special cases, and tell them that you're going to buy a bunch of hardware and hire a bunch of sysadmins and you're going to get started to do work? Does anybody do that? Right. It's pretty rare. Most people, you find out, what do? You go, you swipe your credit card at Amazon or Rackspace or something like that. You get your capacity, you get started, you do some work. It allows you to go very fast, very cheaply, and you focus on what it is you want to build and deliver and not focus on trying to run this underlying infrastructure. Right? So I keep hitting that other button. Okay. And for our world, what's happened is the social mobile cloud has dramatically accelerated social change in ways that were absolutely unanticipated and I don't think could have existed prior to these technologies coming into play. And a classic example of this is Arab Spring. It was the ability of the groups in Arab Spring to continue to communicate despite the fact that their totalitarian regime governments were trying to shut them off that enabled the Arab Spring process and the Arab Spring protest to come to whatever the fruition is that we're going to find out here in a little while, right? We're still trying to figure out what all this means, all right? Okay, and fundamentally in our world, what's really important is that this social mobile cloud thing has completely altered the flow of information on the entire planet. When I started as an analyst years ago inside the CIA, the world was pretty simple. it was the world of the few to the many in terms of information flows, right? So you had NBC, and you had CNN, and you had the TASS, and you had the Times, and you had, the Washington Post. And what you had was the classic model of there were a few generators of information all telling the rest of us how and what to think, and that was how things were distributed. The social mobile cloud world has completely inverted that model, and has gone to this complex many-to-many model. And I got to tell you, we really like the few to the many model. All right? It's really easy to take advantage of this model, right? When everybody is talking and everybody's sharing information, right? What's really interesting is that while there's a whole lot of noise out there, and there is signal that we have to be able to find, and that is, I think, one of the predominant problems of big data in the world is how do you find how do you find a signal in ever increasing seas of noise? Okay, now. You think that's complex, and I think you know this. In fact, the health guy, Aetna, was just talking about this a little bit, and others, is that there's these three emerging forces, all right, of nano, bio, and sensors. All right? And so when you begin to think about this world, you're already a walking sensor platform. You guys know this, I hope, right? Which is that your mobile device, your smartphone, your iPad, wherever it's going to be, has got just any number of these things. In fact, I think this is a limited list of what's inside these devices and what's going to be emerging inside these spaces, right? So as you walk around, you yourself are a walking mobile sensor platform. And as you walk around, by the way, remember I told you mobile is not secure, you are aware of the fact that somebody can know where you are at all times because you carry a mobile device, even if that mobile device is turned off. You know this, I hope. Yes? No? Oh, all right. Well, you should. All right? Because it's really important to begin to think about that, okay? And what's happened is that if you're a Star Trek fan, like I was when I was a kid, right, what's turned out is that this mobile platform, your smartphones, have turned into your communicator. They're becoming your tricorder. They're becoming your transporter, right? How do you get on an airplane these days? Do you walk up with a piece of paper like I do? Because we don't do mobile very well in my place. No, you walk up with your little boarding pass, symbol on your thing, and you wave it in front of the magic thing, and it gets transported to wherever it is you want to be able to go. But it's also becoming a mobile health platform, right? So right now you can buy plugins that can be, for becoming a pacemaker. They do blood sugar monitoring, insulin control, health, all these health monitoring things. The health industry itself is looking very hard at how can we begin to do remote health monitoring to you so that we can continuously pay attention to what's happening to you and your body, and then be able to do things like remote tune-up. All right? So Gus talks very fast, and so I'm just very worried about the fact that somebody's going to hack my remote tune-up and crank up my little pacemaker thing, and then I'll talk a whole lot faster to you guys. But this is something you got to worry about, because when you think about cyber threats as they emerge, it's not just against your business. Ultimately, it's going to be against you, and your health are things that are going to become at risk if you're not careful. Okay? And in fact, if you think about your mobile sensor platform, there's a really cool little app, Actitracker. It's a little Android app. Have you guys seen this anywhere? Right? What they have discovered is fundamentally they take your 3-axis accelerometer that's in your phone. I actually carry a Fitbit. You guys know the Fitbit, right? It's just a simple 3-axis accelerometer, right? We like these things because they don't have any, they can't, well, I won't go into that. Okay. All right. Anyhow, but so what happens is what they discovered is just simply by looking at the data, what they can find out is with pretty good accuracy what your gender is, whether you're tall or you're short, whether you're heavy or you're light. But what's really most intriguing is that you can be 100% guaranteed to be identified by simply your gait, how you walk. All right? Now, this could be a really good thing. So think about this as a security app, right? If you're walking along and you want to access your bank code, maybe it can become simplified because they can, with absolute assurance, know it's you by your gait trying to do something with your bank, right? On the other hand, if you don't want to be found or you want to protect yourself, maybe you don't want to have somebody know what your gait looks like so they can figure out where you are at all times. Right? What's curious is as you begin to put these things together, the inanimate becomes sentient, right? So we're already seeing this happen, right? There was a lot of talk. IBM talks about their smarter planet. Google has their self-driving car. You got machines that know your needs, right? At the last CES show, right, did you ever read the article about the refrigerator? Right, that reads your items as you put them in and take them out, and then we'll send you an email on your smartphone to tell you to, you put the milk in, you take the milk out, you put the milk in, you take the milk out, milk doesn't go back in, sends you an email, says go get your milk, right? My dystopian view of the future is the following. On Friday evening, it's really tired, you had to work late, I'm going to get into my self-driving car, right, I'm going to say take me home, and it's going to take me where? Safeway to get the damn milk. All right? Why? Because it knows better, because you were told to go get the milk, right? So anyhow, some good things here, but maybe not so good things. All right, okay. But when you put them together, this really works well, right? Because it allows, if you think about it, the potential for this is enormously good, all right? And you know this, drive radical efficiencies, the ability to be able to dynamically route you in bad traffic so that you can optimize your time and minimize your fuel consumption or something else like that is a really great thing. We've already talked about social engagement, help us get green, we talked about health. These are all wonderful, great things, okay? All right. Stop and prevent crime. Oh, that's a really interesting one. Anybody see the recent article where they did a study? You know, London's the most cameraed city on the planet. And the argument for London putting all the cameras was it would help them stop crime. Do you know how many crimes they can how many crimes were stopped that they can definitively tie to the camera? Anybody know the answer to this? All right. 1. Okay. So anyhow, it's calling into question some of these things. All right. And the issue we face is, remember I talked about this big world of data from social mobile cloud. When you put in the sensor world, then of course this becomes a real interesting problem space, right? Particularly for us. Because sensors are unbounded. They're just little pieces of silicon that we want to be able to put out any place. And, you know, they go anywhere. They're really simple to do. Sensors are promiscuous. They never in a signal they didn't like, and they're indiscriminate. They'll process any signal that they get. Okay? And then when you go to this Internet of Things that was talked about earlier, everything becomes connected because everything is a sensor, everything talks to each other, and the volume of this just explodes. And so what humans are able to do pales in comparison to what's going to emerge in the sensor-connected world. Okay? And that's the really big challenge of our future. So yourself, why do we care about these things? We care because of the fact that there are signals in all this information that matter to us to be able to protect national security. We care because we have to understand what's going to be going on in the world so that we can inform our policymakers. We can be ahead of these trends, problems, and issues as they emerge. We care because we do want to stop the next underwear bomber before he gets on the airplane and tries to light his pants on fire. All right? Okay? We care because, I have to be careful how I say this here, it can be a good thing for you and your friends to know where you are all the time. All right? In my business, that could be not such a good thing, and so we care how all this world evolves. Okay? And we care because information is vastly different in this world than it is in the previous world of human-curated intelligence. And so that's a great chart down the bottom there, the sort of purplish blob and the greenish blob. Okay? One of those is the world according to the Universal Decimal Classification System, which when I was in school was called the Dewey Decimal System, dating myself. The other one is the world of information according to Wikipedia. All right, so the purple one is Wikipedia, the green one is Universal. Which one do I believe? Which one do you believe? How information organizes? Anybody? I know what I believe. I believe in the Wikipedia one. Okay? All right, so what's the impact of big data for us? And the impact is it really helps us understand what's going on in the world, to know what we know so that we know what our gaps are, so that we can do our jobs much more effectively. It takes us a long time with some very expensive assets in order to figure out how to fill in the gaps. And we don't want to be collecting information that is unnecessary that we can already find out through other mechanisms, such as what's happening out in the social media and things like that. All right? And this has some pretty profound implications. And so what I'm going to talk to you about today in my last 6 minutes is what I call the 4 rules of big data. All right? And this is the way we're looking at this world. So number 1, it's the data, stupid, right? Remember James Carvell's economy is stupid. 2, it's going to be power to the people. 3, we're going to talk about latency breeds contempt. And 4, everything is in context. And everything is in your context in this future world. Okay? So number 1 is the data, stupid. All right? So a little history lesson in our world. All right? Sounds really mundane to you guys, but this is a hard-fought and hard-learned lesson in our place. Sophisticated tools, no matter how slick your tool is, if it doesn't work on my data, it's fundamentally useless. Okay? And our users are going to opt every time to use a mediocre tool where the data exists than to take the most sophisticated thing you can deliver me and tell me how beautiful and shiny this object is across the board. Okay? So, and this is because our job is to figure out what's going on in the world of information, right? We have to put it together. We have to figure out where the plans of tissue are adversary. We have to be able to connect the dots, okay? And our problem, so the problem with big data is the following. All right? Can you guys see that? All right. Okay, this is true. All right, so the database of useless information is 500 million gigabytes. The database of useful information is 5K. The problem, our problem is which 5K? Because we have learned through a long history that information has time value. much like money has time value. And the value of any piece of information is only known when you connect it with something else which arrives at a future point in time. And if you throw away in our world information because you didn't think it had any value, or you chose not to bring in or collect information because you didn't match what you thought your needs were at that moment in time, you won't have information to connect together as new information and new events emerge in the world. And so our problem is, since you can't connect dots you don't have, it drives us into a mode of we fundamentally try to collect everything and hang on to it forever, forever being in quotes, of course. Okay? All right? And some of these characteristics of big data which has emerged are really simple, right? More is always better, all right? And the reason why more is always better, the signal to noise only gets worse in this world, but the problem is that the reason why more is better is that allows you to do enumeration to understand what's going on in your data and not modeling. Anybody know George P. Box's famous saying about modeling? All models are wrong, some are useful. Right? And the problem is modeling forces you to make assumptions up front, which are all biased by your current view of what's going on. We want out of bias and into actual understanding of what's happening in the world. Okay? The other thing is that users are not data scientists. They're not data engineers. They don't get this stuff. So what we want to make sure can happen in the data world is that we need to be able to imbue our information, the data sets themselves, with sufficient intelligence that the user doesn't have to do anything more than ask a question in order to get value out of the data set itself. If they have to go into tens of thousands of data sets and figure out which ones have information that might be relevant to the question that I'm asking, this is a losing proposition across the board. All right, so next, power to the people. All right. So today, I will tell you today that analytics and tools are hard to use, okay? And that specialists are needed to drive value, and we call these specialists data scientists, and we are actually establishing a new high priesthood of data sciences, all right? Because the information and the skills and the knowledge needed to do these things are very dense, very arcane, take a long time to acquire, all right? But the problem is that it takes a lot of hand creation, and a lot of these things that are happening are not built for our business space, right? And then, so this world of the new priesthood is driving these fields we talk about a lot, data scientists, information engineers, things like that. And a data scientist, according to Wikipedia, has to have fundamentally all these skills. How many people on the planet have these skills? Right? Not many. Now, granted, every university on the planet has started up a data sciences program, which is good news, but it's sort of things thinking. So, our belief, very simple, big data democracy wins. The goal we have is I have to be able to get the power of big data and the analytics into the hands of the average user. The only way that the real value is going to be realized by us or even in the commercial sector and by individual companies is when everybody has access to a tool and the data in order to get their jobs done and they don't have to worry about it. Okay? So tomorrow what we want are really elegant, easy-to-use tools. I want the machines to do the heavy lifting. All right? And we want to get out of simple things like search. Search is so broken in this petabyte world, petascale world that we're talking about. Okay? So we have this thing we call the 7 constructs, universal constructs for what we want to do analytics to do. We care about people, we care about places, we care about organizations, we care about time, events, things, and concepts. Right? And what we want is the analytics to be as simple to use as Excel, right? Functions. Right? You go to Excel, you put in the little equations, equal standard deviation, open parentheses, select a list of numbers, close parentheses, you get an answer back. You know that's correct, right? We want a tool, say for people, where I want to understand the relationships between a bunch of folks. I want to say relationship between open parentheses, list of names, close parentheses, and what do I get back? I get a nice network graph that explains to me how all these people are related in any number of different ways based upon what I want to be able to do. I believe it's got to be that simple for our folks to be able to use. And we want people to be able to put these things together in ways that you can't possibly anticipate. And I want them to be able to change so that they themselves can build what are much more complex outcomes based on fundamentally simple building blocks. So this is a case where I want to be able to say, tell me about all the people involved in Arab Spring. I want to understand how their sentiment analysis changed over time and put it on a map as a heat flow, right? And that's all I want my user to have to do, is simply do that in some sort of Visio mechanism and be able to see what comes out on the other end, okay? And so we got to keep it simple just for them. All right. So I got to go on because I'm running out of time here real fast. So latency breeds contempt. It's all about speed. All right? I got to tell you, speed is the only thing that matters in our world, and I think it's going to be the only thing that matters out in the commercial side because simply we don't want to wait. All right? In fact, what drives my user crazy, my user's nuts more than anything, is when they think it takes too long for something to occur. right? So I think we're moving into a world where we're heading into, we already, this is happening, right? In fact, we've got these equivalent, moving to real-time, equivalent real-time MapReduce jobs, getting out of MapReduce, which is flexible, powerful, and slow, until MapReduce, or the flexibility of MapReduce, which is flexible, powerful, and very fast. We actually want to push into what we call petascale in-memory architectures to do distributed analytics and things like that, okay? And this is what's driving a lot of these technology shifts that you read about all the time. All right, and what we think this is doing is going to drive new computing architectures that are going to radically shift how things happen in the world. All right, so I'm sorry, I can't, is that saying I'm over time or I'm under time? I'm okay? All right, okay, thanks, all right. So the next thing is that finally it's everything in context. All right? Everything in your context, and this matters, all right? Because this is the world that we believe we have to be able to build. And it's got to be in your frame of reference, because anything else is somebody else's frame of reference, right? So the purpose of the widgets is to be able to build your web top, or whatever you want to call it, in the context using the tools and capabilities that you need to get your job done, right? What's the purpose of all of the stuff that's emerged in the big data world about schema on read, right? What's the purpose of schema on read? It's data out in the context to which you need to take advantage of it, right? I want, as I said before, user-assembled analytics in the context of the problem, the question they want to be able to ask, and then all this takes computing in context, all right, to meet the demand of the job that you want to be able to run, and that's what elastic computing in our world is about. Okay, so some real quick closing thoughts, all right? I think we're at high noon in the information age, and I say this because of the following. It is really very nearly within our grasp to be able to compute on all human-generated information. You know what's nice about humans compared to sensors? Is you can only do so much stuff in 24 hours, all right? And so the fact that you're sitting here taking notes, taking pictures, whatever you want to be doing, or just listening, you're only doing that, right? You can't do so many other things, and you only can generate so much data. So we're at this point, and if you don't believe me, let's go back to my Facebook example, where already 1/7 of the world population and 35% of the world's digital photography is already in one place, if you want to begin to think about it that way, and the things that they can do, right? The inanimate is becoming sentient, okay? And when it becomes sentient, I told you my dystopian thing. All right, we got this third wave of computing which has emerged, which are cognitive machines. Watson is the critical example of this that we can think about. They're critical. The interesting thing about Watson is that Watson is to the cognitive machine as the original IBM PC 8088 is to what we can do today on existing machines. This is a world which is going to explode upon us, and cognitive machines are going to do everything from medicine to financial trading to helping us with our intelligence analysis across the board. All right? And so what's happened is that technology in this world is moving faster than government or law can keep up. It's moving faster, I argue, that you can keep up. You should be asking the question of what are your rights and who owns your data, right? This is a question that I argue that you ought to put on the table, all right? As I mentioned before, it's driving the pace of social change in ways we can't anticipate, and it's creating an interesting world, and I'm not going to talk about the cyber threat thing because actually I think we're out of time. So thank you very much. All right. Thanks, appreciate it.
Thank you so much. That was awesome. I think we're getting ready for lunch, but people can find you, I'm sure, floating around. Thank you once again to Gus Hunt, CTO CIA. And I don't know about you, but I'm going to go throw my phone in the river during the lunch break. Lunch is right now. It is sponsored by Chartio. Thank you, Chartio. Visit the exhibit area out there. There are workshops. You saw in the first morning break that some of them had standing room only, so please be sure you get there soon. There's an IBM sponsor workshop in the Oceania.